students, welcome back to Wisdom Academy YouTube channel. Today we are going to learn about parallel plate capacitor. In the previous video you have learned the principle and the concept of capacitor. Today we are going to extend that and learn about parallel plate capacitor. As the name says, it has two parallel plates separated by a small distance t. In the principle of capacitor itself, I told you that it will consist of two plates and they will be charged plate, they will have opposite charges. So suppose here I have completely positive charge and here I have complete negative charge and separated by small distance d. This arrangement will be known as parallel plate capacitor. Now if you recall my video where I have talked about electric field due to a infinitely charged plate, which was there in the previous unit, application of Gauss law, I took this kind of condition where I took two plates having charge densities, similar charge densities and dissimilar charge densities. So you can see that video, you will come to know if this is having plus sigma and is having minus sigma charge densities, then the electric field in this region will become 0. How it becomes 0? You can refer that video. And electric field inside the plate E net, that will be equal to addition of both, that is sigma by 2 epsilon naught plus sigma by 2 epsilon naught. That will be equal to sigma by epsilon naught. So what is the electric field inside the capacitor? That is sigma by epsilon naught. Okay. Now we know the relationship between electric field and electric potential. What is that? Electric field is negative gradient of potential difference. So what happens? This is electric field, I can write like this also. This is electric potential and this is distance. So I can relate electric potential to be electric field into distance. So now electric potential, that is V, will be equal to E into the distance here is d. So we know that E is sigma by epsilon naught, so potential you get as sigma by epsilon naught into d. Let this be equation number 1. And we know very well about the capacitor, that is Q is equal to CV. From here I will get capacitance. Since Q is equal to CV, capacitance is equal to Q by V. What is Q? Sigma is equal to Q by A, area. So Q will be equal to sigma into A. So from here it will become sigma into A divided by V is sigma into D, epsilon naught will go above, these two will get cancelled. So here C is equal to epsilon naught A by D. C is the capacitance of the parallel plate capacitor, epsilon naught is the permittivity of the free space, A is the area of the plate and D is the distance separation between these plates. Remember that epsilon naught will be used only if the medium between them is vacuum. There is no medium between the two plates. If we introduce some medium, then the concept of dielectric constant will come. I will tell that in the coming video. Also, I have talked about this when I talked about relative permittivity in the first video. Let us take one question. A parallel plate capacitor has plates of area 200 cm square and separation of the plate is 1 mm. So they have given the area of the plate and they have given the separation between the plate. What potential difference will be developed if a charge of 1 nanocoulomb is given to the capacitor? And second part is, if the plate separation is now increased by 2 mm, what will be the new potential difference? So first part, you have to find the potential difference and the charge value is given. If we find the capacitance, then it is easy to find the potential difference. So what is the capacitance formula of parallel plate capacitor? Just now we have learned C is equal to epsilon naught A by D. Everything is given. Epsilon naught value is 8.85, 10 to the power minus 12. Area of the plate is 200 centimeter square, so 10 to the power minus 4 will come, divided by D, distance 1 mm, so 1 into 10 to the power minus 3. So when you solve this much farad, you will get as the value of capacitance. Then what you have to find? You have to find the value of potential difference. So we know that Q is equal to CV. So from here we know that potential difference will be equal to Q by C. So Q is 1 nanocoulomb. So 1 into 10 to the power minus 9 coulomb divided by whatever value you get from C of here. And you put here, that much volts will be the potential difference. Then in second part they have asked you, if the plate separation is now increased to 2 millimeter, what is the new potential difference? So from 1 millimeter it becomes 2 millimeter. So what has happened? The D dash has become 2 times the original distance. So we know that C is equal to epsilon naught A by D. So as the D will increase, capacitance will reduce. Also we know that Q is equal to CV. So from here I can write that V is equal to Q by C. So as this C is reducing, V will increase. So here what they have given, D is increased by 2 times. So C will reduce by 2 times and V will increase by 2 times. So whatever V you have got from here, the new V dash will be 2 times the old V, this V value. So when you put it here, that much volt will be the new voltage if the separation is becoming 2 times. I hope you understood, and from this question what you understand, that capacitance depend upon these 3 things. It depends upon the permittivity, that means the medium. If the medium will change, capacitance will change. C depends upon area of the plate also. If the area is more, capacitance is higher, area is less, capacitance is lesser. And D, it is inversely proportional. That means if the distance is lesser, capacitance is higher. If distance is higher, capacitance value will be lesser. Now we are going to see capacitors in series and parallel. So in a basic circuit, I am going to attach capacitors in series first. So let this be connected to a source of potential difference. Let this potential difference V have positive and negative terminal. So this will acquire positive charges. When this acquire positive charges, by the principle of induction, it will acquire negative charge. This is plus Q, this is minus Q. Same way this will be plus Q, this will be minus Q, plus Q and minus Q. So this plate gets a charge and this plate acquires charge. Again this plate gets a charge, this plate acquires charge. So the potential difference across each capacitor will be based upon what capacitance it has. So V1, let this be V2 and let this be V3. But the net potential V will be equal to V1 plus V2 plus V3. Now how V and C are related? We know that C is equal to Q by V. So we can write V is equal to Q by C. So I can write V net is equal to Q by C1 plus Q by C2 plus Q by C3. And what is V net? V net will be equal to Q by C net, that is equal to 1 by C1 plus 1 by C2 plus 1 by C3 if I take Q common. Q will get cancelled and I get 1 C in series, that is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So if the capacitors are added in series, their equivalent capacitor will be the reciprocal sum of them, that 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Don't confuse this with resistors, what we learned in 10th standard, because resistors in series was R1 plus R2 plus R3 and in parallel it was opposite, but here it is little different. So please don't make any mistake in this. Now what I am going to do, I am going to connect this capacitors in parallel. So let this be having, and complete thing is connected to a source of potential difference V, and let this be C1, let this be C2, let this be C3. So charge will also get divided, what is going here. So let here Q1 go, let here Q2 go and let here Q3 go. What remains constant? What remains constant is potential remains constant, but what varies is charge. So what Q came here, that Q is split into Q1 plus Q2 plus Q3. We know that Q is equal to C into V. So from here I can write C parallel into V is equal to Q1, we can write C1 V plus C2 V plus C3 V. So if I take V common outside, it will be C1 plus C2 plus C3, and here I have C parallel and into V. VV gets cancelled, I get C parallel as C1 plus C2 plus C3. Same what we saw in resistance, I mean opposite of what we saw in resistance. So we saw now that capacitor, when it is connected in series, 1 by C series is equal to 1 by C1 plus 1 by C2 plus 1 by C3, and same capacitors when connected in parallel, then C parallel is equal to C1 plus C2 plus C3. Let us see this question. Here if you see this capacitor and this capacitor are in parallel, So I can simplify this circuit like this, where this 10 picofarad I will draw and then these two I will write in parallel. Just to make it simplified circuit, I am doing this. This 6 volt obviously, this is 5 picofarad and this is 5 picofarad. So this 5 and 5 are in parallel, they will get added up. So this will give 10 picofarad resultant. So what I will get here is 10, already it was 10 picofarad was there. This also becomes 10 picofarad. So when I connect with 6 volt supply, what I get this? So for finding the resultant of these two, 1 by C series is equal to 1 by 10 plus 1 by 10. So 1 by C series is equal to 2 by 10, that is equal to 1 by 5. So C series is 5 picofarad. So 5 picofarad is the net capacitance which is starting from here. So finally, if I try to get what starts from here, this net thing is 5 picofarad. This is having 6 volt battery plus and minus. Or this 5 picofarad and the 6 volt battery, how much charge it will create? So we know that Q is equal to C into V. What is C? 5. What is V? 6. So it is 30 charges, or I will write 30 coulomb Q. So 30 coulomb is the charge. Now 30 coulomb when it starts from here, definitely 30 coulomb will go for this, and when it keeps on moving, once again I should write picocoulomb, because here I have multiplied volt with picofarad, so I should get picocoulomb, and so 30 picocoulomb will touch here, and when it moves, it goes, it gets divided here. So what goes here will be 15 picocoulomb, and what goes here also will be 15 picocoulomb. So in today's video, we have learnt about capacitor, which is parallel plate capacitor, and we have learnt what will happen if the capacitors will be in series and if it is in parallel. We have solved a numerical based upon this. In the coming video, I will try to solve many other numericals based upon this. You can also try in home. There are lots and lots of complex circuits where you will find it difficult to solve. So please practice as much as possible to gain confidence in numericals based upon capacitors. Apart from that, we also have capacitance of spherical capacitor and cylindrical capacitor, which is not in the portion of CBSE, but it is very important for the competitive examination. I will try to make a separate video for that too. With this, I am winding today's session. In the next video, we will learn about dielectrics kept in a capacitor. So till then, please be safe, take care, like the video, subscribe my channel and share it with your friends.